Hello students. Today we are going to discuss about these four topics under electrochemistry, the third chapter or third unit in our class 12 chemistry syllabus. So as we know, electrochemistry is in physical chemistry section. The first 5 units are from physical chemistry section and it contains 23 marks in your final exam. These are the topics to be covered under electrochemistry. You already studied redox reaction, EMF of a cell, standard electrode potential, Nernst equation and its application to chemical cell, relation between Gibbs energy change and EMF of a cell. Now we are going to discuss these four topics: conductors in electrolytic solution, specific and molar conductivity, variations of conductivity with concentration, and Kohlrausch law. Before starting, we need to remember some basic concepts. First one is, we know electricity is a flow of electrons generated by a battery when the circuit is completed. Just go through this diagram. Here you can see battery is attached with two electrodes. Positive electrode is called anode and negative electrode is called cathode. And in between two electrodes there is a solution of electrolyte that is called electrolytic conductor. Now from this we have to go further. First one is, what do you mean by conductors? So conductors are those substances which allow the passage of electric current through them. And what is insulators? Insulators are the substances which don't allow the passage of electrical current through them. So we know conductors, when we use the term conductor, some metals, wires, copper wire, nichrome wire come in our mind. And insulator examples are rubber, wax. We already know that. Now types of conductors. First one is metallic conductors. So examples are all metals. There are metallic substances which allow the electricity to pass through them without undergoing any chemical or physical change. Now in this diagram you can see there are lots of free electron available in metals. So this free electron helps for the conduction of the electricity. Next we need to know about electrolytes. So there are substances which allow the electricity to pass through them in their molten state or in the form of their aqueous solution and undergo chemical decomposition. So here we need to understand about molten state and aqueous solution. Molten state means when you give heat to a solid substance, it get melts and form liquid and come into liquid state. But when that solid is added in water, then it dissolved in it. So when we heat sugar, we get molten sugar. That is the molten state or liquid state of sugar. When we dissolve sugar in water, that is the aqueous solution of sugar. Understand? Okay. Next, second one is electrolytic conductor. It is also called as ionic conductor. Here electrolytic solution and molten salts conduct electricity through the migration of ions. When the current is passed through an electrolyte solution, decomposition and changes occur in the composition of electrolytes. Okay, there is a diagram. You can clearly see that when electricity is passed, then negative ion, that means anion, are moving towards positive electrode, that is anode, and positive ions, that is cation, moving towards negative electrode, that is cathode. So now we need to know the factor affecting metallic conduction and electrolytic conduction. So first one is factor affecting metallic conduction. So it depends on number 1, nature and structure of metal. Number 2, the number of valence electron per atom. Number 3, density of metal, and another one is temperature. On the other hand, electrical conductance, or we can say ionic conductance, depends on the following factors. Number 1, nature of electrolyte. Number 2, nature of the solvent and its viscosity. Number 3, size of the ions and its solvation. Number 4, concentration of the electrolytic solution, and last one is temperature. So this is your NCERT page. Go through this, and if you have any query, you can ask.
Here you can see a beaker type thing which contains water and one container having salt. So here we are using table salt or sodium chloride. Let's see what happens if we add some sodium chloride in water. Observe carefully. Sodium chloride contains. Now if we add more, it also get dissociated and dissolved in aqueous medium. That means ions are dissolved. So this kind of electrolyte is called strong electrolyte, which dissociate fully. Now what happens if we use strontium phosphate? Now we are using strontium phosphate. Let's see. You can clearly see that some molecules of strontium phosphate gets undissociated, or you can say there is a dynamic process between ion get dissolved and ion gets accumulated or precipitated. So this kind of salts are called sparingly soluble salt, which cannot get dissociated fully.
Next, I am going to correlate class 11 knowledge with this portion. You already studied that degree of dissociation alpha. What does it mean? Alpha means number of molecules dissociated divided by total number of molecules. For strong electrolyte, that means which dissociates fully, alpha should be 1. But for weak electrolytes, alpha is less than 1. So alpha is represented as number of molecule dissociated when we add something or add some solute in particular solvent. If it dissociates fully, then number of molecule dissociated and number of molecule added, both are same. That means it becomes 1 for strong electrolyte. But if it is weak electrolyte, then it doesn't dissociate fully. Suppose you add 10, so minimum, or you can say less than 10 number of molecule can be dissociated for weak electrolytes. I am adding some simulation after this, so just go through that, you can get a proper idea. Now in this slide we can see, according to the degree of dissociation, electrolytes can be classified into the following. strong electrolytes are compounds that dissociate to a large extent into ions when dissolved in water. So alpha greater than 30%. So up to 100% it can go, because when alpha is 100%, that means all the molecule get dissociated. Okay, next one is medium strong electrolytes, that is alpha ranging from 2 to 30%. Examples are H3PO4, H3PO3. Next one is weak electrolytes, are compounds that dissociate to only a small extent. In simulation you can get a clear picture, so just listen. So here alpha must be less than 2%. For example, NH4OH, H2S, HCl, H2CO3, etc. And the last one is non-electrolytes, where alpha is equals to 0. That means those are the compounds that don't dissociate when dissolved in water. Okay. Now, what are the type of motion of ion in the solution? Ions get diffused. That means through diffusion, through convection, or through transfer, it can move. Diffusion means due to difference in concentration. Convection is due to the difference in density or temperature. And transfer means due to electric field. Only the transfer can cause net electricity. Now you can clearly differentiate between metallic conduction and electrolytic conduction.